Good morning, boys and girls. We are on page 114 and lesson 19 problem set. So, problem number 3 asks you to list the properties shared by all of the squares that you worked with today. So, the first thing that we know about squares is that squares have 4 sides that are equal in length. So, I'm going to draw a square right here so you guys can kind of see. It kind of looks like a rectangle. There you go. That's more of like a square. So squares have 4 sides that are equal in length. That means this side and this side and this side and this side are all equal to each other. They are not longer, they are not shorter, they're exact same lengths, okay? Number 2, for 90 degrees or right angle. 90-degree and right angle means the same thing. They all have 90-degree angles because they are squares, rectangles, same thing, okay? Number 3, opposite sides are parallel. So this side is parallel to this side, and this side is parallel to this side. But in reality, all of them are actually parallel to each other because they all have the same length. Oh no. No, to be parallel, you need to have the same side. Sorry, yeah, that's right. So the arrows are correct. So they are parallel to the opposite sides. Number 4, the diagonals are perpendicular bisectors. When we are talking about perpendicular bisectors, that basically means that when I bisect my square, those lines right there, they have the same measurement. So this is 2 centimeters, and so is this side 2 centimeters. And this side is 2 centimeters, and so is this side is 2 centimeters. So they all have the same perpendicular bisectors. That's what it means. Okay, for problem B, it asks you to list the properties that shared by all the kites that you worked with today. So kites have 4 sides, right? So kite looks like this. Kites have kites have 4 sides, and you see the 4 sides, okay? Kites have 2 sets of adjacent sides that are equal in length. So what that means is that they are the same length in every single side, okay? Number 3, they have at least one set of opposite angles that are equal in measure. So this measurement is equal to that measurement, and this measurement is equal to that measurement, okay? So the angles are the same when they are opposite to each other. 3, they have at least one set of opposite angles. Oh, I just read that one. 4, diagonals cross at right angles. One bisects the other. So what that means is if I were to draw my lines out, this is considered a right angle, right? So they bisect each other. So they're equal in measure. Now, problem C. When can rhombus also be called a square? So if you notice, a rhombus and a square are basically the same. It's just tilted, right? So this is a square, and this is my rhombus. Not very good at drawing that. Okay. So a rhombus can also be called a square when it has 4 right angles. So if this side and this side and this side and this side is an angle, 90-degree angle, then they are the same. They can be called the same. If I were to draw this correctly, it's a tilted, I don't know if that helps. It's a tilted square. So all measurements should be the same. For problem D, a kite can also be called a square when it has 4 sides of equal length and 4 right angles. Okay? And when can a trapezoid also be called a kite? A trapezoid can also be called a kite when it has 2 pairs of equal adjacent sides. So they are equal to the sides. I'm going to turn the page. Page 15, draw a kite that is not a parallelogram on the grid paper. So I need to draw a kite that is not a parallelogram, meaning that they do not have any parallel sides. So this is my unique kite that does not have any parallel sides. Okay? Now, list all the properties of a kite. First, a kite has four sides. Second, adjacent sides are equal. Okay, so you notice there are 1, 2, 3, 4, and all sides are equal. This one is not so much equal, but if I were to bisect this one, this side is equal to the other side. Diagonals form right angles. So diagonal meaning like if I were to draw a bisect line, then they would have right angles. Problem C, when can a parallelogram also be a kite? A parallelogram can also be a kite when it has two pairs of equal adjacent sides. Rhombuses and squares are examples. So a parallelogram is a rhombus and a square. Two, if rectangles must have right angles, explain how rhombus could also be called a rectangle. A rhombus can also be called a rectangle when all four sides are equal and all angles are 90 degrees. Okay. And lastly, number 3, draw a rhombus that is also rectangle on the grid paper. So this is a rhombus that is also considered a rectangle. A rhombus that is also considered a rectangle is basically a square. They all have the same sides. This little mark right here tells you that the sides are the same. So that is a square. Turn the page. We're on page 116. It says Kirkland says that figure EFGH below is a quadrilateral because it has 4 points in the same plane and 4 segments with no 3 endpoints coliner. Explain his error. So right here is the shape that they give me. So this is considered a complex quadrilateral. This shape doesn't have a shape like a rectangle, rhombus, trapezoid, rectangular prism. It's called a complex quadrilateral. Why is it called complex? Because it is difficult. It's not like a simple shape. It's a complex shape. So for the purposes of this module, we will say it is not a quadrilateral. Now, these are types of quadrilaterals. We have convex, we have complex, and we have concave. So this you will learn more about later on, but any shape that is complex kind of looks like it's cross triangles. So if you see here, there's this little triangle, and then you have another triangle here. And notice the triangles aren't equilateral or equal on all sides. They are very different. This one's like a smaller triangle right here, and this one is much more larger. Okay? So let me zoom out a little so you can see that. And that is basically all for page 116 and for lesson 19 homework.